Hi and welcome to Maths Made Easy. This is going to be the first in a series of videos aimed at high school students and late secondary school students who may want to take their maths further than what they've seen in the classroom, and possibly get a brief introduction to some topics you may cover in a first year university course. This is also great for those who have been accepted onto a uni course and want to get an idea of what they're going to see in their first term and kind of make the transition a bit easier. Okay, so let's start with our first topic of sets. Now, a set in maths is just a collection of objects, and we denote a set with these kind of curly brackets like this. So, for instance, we may write something like this: 1, 2, and 3, and we close the curly brackets. And this is just what we call a set of the numbers 1, 2, and 3, separated by commas here. And this is just a way to denote a collection of these three numbers all as one object. Now, by convention, we do this thing which may seem strange at first, but it makes a lot of sense to not include multiples. And so we say that something that was, for example, 1, 2, 2, 3, we just get rid of any multiples in the sets. We just say that is just 1, 2, 3. That's the same as our set above. These are the same sets. You could write this, but by convention, we'll remove any multiples and we'll just write it like this. They're the same set. Okay, now you can take two sets and you can kind of do what we call operations on these sets to get a third set. So let's have some examples here. So we write this U and we called it the union, and we also have this kind of N and we call that the intersection. So how do we actually use this union and this intersection on sets? For example, let's take our X kind of as above as 1, 2, and 3, and then our Y as a new set. Let's make it 2, 3, and 4. Now, we can perform the union and the intersection on these sets and we'll get a new set out. So the union gives us everything that's in the X and the Y. So for instance here, X union Y gives us a new set. That's 1, 2, 3, and then also 4. So you can see this is a set that's everything in X, 1, 2, 3, and everything in Y, 2, 3, 4. And just like we were talking about above, we didn't do the 2 and the 3 twice, even though they're in the X here and in the Y, because multiples kind of get omitted. And intersection now. This is the second main operation you'll see all the time with sets, and the intersection is the operation that gives you everything that's in the X and the Y. So let's see here, X is 1, 2, 3, and Y is 2, 3, 4. So X intersection Y is everything that's in X and is in Y. So 1 is only in X, so that's not in X and Y. 2 is in X and it's in Y, so we include that. 3 is in X and it's in Y, so we include that. But then 4 is only in Y, so we don't include that. So what we've done here is we've taken two sets and we've either found a way to join them to make them bigger, or intersect them, make them smaller, and get something that's in both of them. It's the common elements. So that's union and intersection. Now let's take a look at some other little bits of notation that you'll see all the time in set theory. So first of all, we want to say whether something is in a set or not. So let's take here our X as 1, 2, 3, just like above. And now, how do we want to denote if something is actually in this set X? So for instance, 1 is in the set, 2 is in the set, but 4 is not in the set. We want a nice way to write that. So what we do is like this. We say 2, and then we use the little e here for element. So 2 is an element of X. Whereas, what if something's not an element? Well, we do the same symbol, but with a slash through it. So the slash kind of means like, no, it's not in that. So 4 is not an element of X. And in the same way, we can have some notation to say whether a set is contained in another set. So let's say our X is 1, 2, 3, and now we've got this set 1, 3. So you can kind of see that this set is like within this bigger set of X, because 1 is in X and 3 is in X. So all this is missing is the 2. So what we say is this is a subset of X. So that's subset. And this was element. So 1, 3 is a subset of X because every element in this set is an element of this bigger set. And quite naturally, like before, we need a way to say if something's not a subset. So let's take 2, 5. Now, although the 2 is in X, the 5 is not in X. So we write the subset, but then just like before, we cross it out. So 2, 5 is not a subset of X. And those are your introductory points on set theory. Thank you very much.